Hello, thank you for joining this video. This video is going to talk about composite figures and their surface area. Composite figures can be tricky just because you have to visualize what it is that you are actually calculating and kind of reorient the object. The first step in dealing with surface area calculations for composite figures is just to identify the shapes that are given. So I'm going to go ahead and identify, let's say, the objects. And here we have everyone's favorite. We have the triangular prism. So I'll put this guy in red since everyone loves him. We have the triangular prism. Okay, so we'll need to calculate the surface area for a triangular prism. And then we also have the surface area of a rectangular prism to calculate. So I'll put rectangular prism over here. Okay, and these problems can be tricky just because there are a couple of ways that you can approach these problems. I'm not going to do a net with this because there are so many faces. I would have, I don't know, 5 faces for this object, and then for this object I would have 4. So if you don't mind calculating the area of 9 faces using a net, you can do that. That's one approach. Or you can kind of use, I don't know, some visual aspects and approach it in a different manner. So what I'm going to do is I see most of a triangular prism here, and just to complete it, it's missing this inside wall that it's sharing with a rectangular prism, and I see that wall here. So I know that wall is calculated, but what I'm going to do is I'm going to slide that wall over. I'm going to sliding it over and completing the triangular prism. So I'm going to use the whole formula to find a triangular prism, which is pH plus 2b. And it's important to note in these problems, the triangles have to be your base. Triangles are the base. Okay? So when I do that, I take off this side wall of this rectangular prism, and I don't have this side wall of the rectangular prism, so I'm missing this piece and this piece. So I'm going to treat those empty sides over here, I'm going to treat this as being empty, and this one is empty. I'm going to imagine flipping that over. I'm going to treat those as the bases. So those are going to be my 2 bases. So I'm going to use the formula S equals pH, and I'll have to calculate the perimeter that is going around here, and then multiply by this height there to give me my lateral area. So you'll see all of that when we get there. First, I'm going to go ahead and I'm going to turn my attention to this triangular prism. I need to go ahead and first figure out, okay, what is the perimeter of my base, and I'm treating my triangle as my base. So I'll go ahead and draw a right triangle to help you visualize what we have. So this is our base, and this is 8 centimeters. This distance is 15, and I have to go ahead and calculate my hypotenuse here using good old Pythagorean theorem. So a squared plus b squared is equal to c squared. Now, if you don't visually identify it right away, that's okay. You can square 8, you can square 15, take the sum of this, and then take the square root of each side, but you will get 17. This is a Pythagorean triple, 8, 15, 17. So now I know if I wanted to calculate the perimeter of my base, I take 8 plus 15, that is 23, and then I add that to 17. I get a perimeter of, not 17, 40 square, not even square, 40 centimeters. You can tell I'm ready to go home. So 40 centimeters. The heights. Well, if this is my base and then that backside is my base. The height of this object is the distance between those bases. That makes it the height. So that's going to be 6 centimeters. So height is 6 centimeters. Now, the last part I need to complete this formula is the area of this base, the area of this object. Now, the area formula for a triangle is 1/2 the base of this triangle times the height of this triangle. Okay, so I plug in 1/2 times 8 times 15. And this ends up giving us, let me move down, this ends up giving us 4 times 15, which is 60 square centimeters. Okay, and we are going to have 2 of those. So let's go ahead and calculate the surface area of our triangular prism. 40 times 6 plus 2 times 60. Over here we get 240 plus 120, and these are all centimeters squared, so it gives us 360 square centimeters. Okay, so I have the surface area for my triangular prism. Surface area sub TP for triangular prism. Okay, now I turn my attention to the rectangular prism, and I need to calculate the perimeter of this object. So this is kind of a weird situation where this is hollow and this side is hollow, right? We took this side and we moved it over. So I want to calculate the area that's going around. And when I do that, I need to calculate the perimeter of the base, what we're treating as the base. And notice we took away our 2b, right? We used to have something that would look like this, right? But it's gone. Okay, so when we remove those 2 bases, we're treating this side as the base. So I'm going to go ahead and calculate the distance around it, which happens to be 15 plus 6 plus 15 plus 6. And I'll do that over here. I'll put it in green. So the perimeter is 15 plus 6 plus 15 plus 6. So we have 30 plus 12, which equals 42. Okay? So we have 42, and then the height between these would be 10. Okay, and I'm just going to go ahead and calculate this. So 42 times 10 is equal to 420 centimeters squared. Okay, so all I need to do now is add 360, add 420, which will give us our answer of 720 square centimeters. That is the area, surface area of this composite figure. If you like the video, give it a thumbs up, subscribe. If not, I'll see you later. Bye.